Hello everyone, welcome back to my channel. I'm Riyansh Gandhi, and here we solve advanced problems using basic concepts. We're transitioning over from probability, and now we're going to go into our algebra unit, where our first topic is going to be on polynomials. So what is a polynomial? A polynomial, often known as p of x, is a sum of terms containing whole number powers of x. So for example, 2x squared plus 6x plus 4 is a polynomial. X plus 3 is a polynomial. X to the power of 100 plus 1 is a polynomial. But an example of x to the power of 3 over 2 plus 3 is not a polynomial because the exponent is not a whole number. Alright, so now that we know what a polynomial is, let's get into a few formulas and essential things that we need to know in order to understand polynomials. So, there are two main formulas we should know. For any polynomial p of x, we have that p of x is always equal to d of x times q of x plus r of x. What does this mean? It means that the polynomial of x is equal to the divisor times the q is the quotient, and then the r of x is the remainder. So this is the remainder. Doesn't this kind of make sense? For example, 14 divided by 4 is just equal to, so our p of x, let's just say 14, is equal to the divisor of x, which is 4, times what is the greatest q of x? It's 3, right? So 4 times 3 plus the remainder, 2. So now that we know how this works, let's also take a look at our next formula. But before we do that, we also have to acknowledge one thing about our first formula, where r of x in polynomials is always 1 degree less than d of x. So for example, let's just say d of x is just going to be, let's just say x minus 3, which is a linear term. Then that means that r of x would be constant. So for example, a constant term could be 4, 7, 3. Or let's just say that our d of x was not x minus 3. Let's just say it was x squared minus 7. If it's x squared minus 7, this is quadratic, meaning that our r of x would be linear, or be expressed in the form ax plus b. Okay, so now that we know that, let's get working. Oh, and our one last formula, which is that when p of x is divided by x minus a, the remainder is always p of a. This is a really, really helpful theorem because it can help us solve a lot of problems that we might have with synthetic division. Alright, let's look at our first problem, which actually will involve that theorem. Find the remainder when x to the power of 4 minus 3x cubed plus x squared plus 11 is divided by x plus 2. Okay. So this is a mouthful. We could do this using polynomial division. In case you don't know how that works, that's basically taking x to the power of 4 minus 3x cubed plus x squared plus 11, and then doing your division as if you're doing regular long division, and then saying, okay, x plus 2 times x cubed would be x to the power of 4, and then you'd solve it like this. Now, this you can do, but that would take you an extremely long time. And honestly, who does have the time for that? If you're taking an exam, you're not going to be doing that much synthetic division. So we'll use our polynomial root theorem. It's when it's divided by x minus a. So x plus 2 means that it's just going to be the negative 2. X minus 2 would mean that it would... Okay, maybe I'm not making it as clear. When p of x is divided by x minus a, the remainder is p of a. So when p of x is divided by x plus a, for example, the remainder would be p of negative a. So x plus 2, it would be p of negative 2, or p of negative 2. So p of negative 2 is just what we need to find. So we need to find this expression over here in terms of negative 2, plugging in x. So let's solve this. Negative 2 to the power of 4 minus 3 times negative 2 cubed plus negative 2 squared plus 11. This is equal to 16 plus 24 plus 4 plus 11, which is equal to 40 plus 4 is 44 plus 11 is 55. And therefore, our answer is 55. All right, let's move on to another problem. If two factors of 2x cubed minus hx plus k are x plus 2 and x minus 1, compute the absolute value of 2h minus 3k. Okay, so what does it mean when it's a factor? It means that when you plug it in, it should always result into 0. So, if these are two factors, then we can say that to get x plus 2, we'll take the inverse, which is minus 2, because minus 2 plus 2 is 0. So, we take x equal to minus 2. This should equal to 0 then. So, 2 times minus 2 whole cubed minus h times minus 2 plus k is equal to 0. Then, x minus 1 means x equals 1. Then that means that 2 times 1 cubed minus h times 1 plus k is equal to 0. So now we can solve this. Negative 2 cubed is negative 8 times 2 is negative 16. Minus h times minus 2 is just plus 2h. And then plus k is equal to 0. Meaning that 2h plus k equals 16. Alright, now let's move on to our next one. 2 times 1 cubed is 2 minus h plus k equals 0. Alright, so now we can simplify this. This means that h is equal to k plus 2. So now we can plug that back into our first equation. 2 times k plus 2 plus k equals 16. So let's simplify this. 2k plus 4 plus k means 3k plus 4 equals 16. 3k equals 12. K equals 4. You know, if k equals 4, you can plug that back in to find h. That means that h equals 6. So you need to find 2h minus 3k. That is equal to 2 times 6 minus 3 times 4, absolute value, which is equal to absolute value of 12 minus 12, which is equal to 0, which is our final answer. Well, let's move on to our final problem, which should be the most difficult one. Let p of x be a polynomial such that its remainder when divided by x minus 3 is 2, and the remainder when it's divided by x minus 5 is 4. Find the remainder when it's divided by x minus 3 times x minus 5. This one doesn't seem as straightforward compared to the other ones. We'll have to think a little bit. So, let's look at our formulas again, just to clarify. These are our formulas that we have to look at. We've already used our second formula a lot, but have we really talked about the first formula? Let's really understand it. P of x equals d of x times q of x plus r of x, where r of x is 1 degree less than d of x. Can we try and use that here? Yes, we can. So, let's go down. P of x is our polynomial, and this is when it is divided by x minus 3, so our d of x in this case is x minus 3, times q of x, which we don't know, so I'll represent as q as x, and this is equal to plus r of x, which is, in this case, 2. And p of x is also equal to x minus 5, which is our d of x, times q of x, which we don't know, and then plus our remainder of 4. What is it when p of x is divided by x minus 3 times x minus 5? So x minus 3 times x minus 5 is our d of x, times our q of x. We don't know, but we don't know. Now we need to find our r of x. R of x, you might be tempted to just say, okay, plug in some random value c. But look back at our formula again, where r of x is 1 degree less than d of x. What is our d of x? It would only be equal to plus c if our d of x is linear. But in this case, our d of x is quadratic because its degree is 2 when you expand this out. So we actually cannot represent this as just c. we have to represent it in a linear form. So for example, linear form would be ax plus b. Okay, so now that we have this, let's try and do a little bit of solving. Let's just say we plug in x equals 3 to our first equation. We want to simplify this as much as possible. If we plug in x equal to 3, then these terms right here, this will actually just equal 0. Because if you plug in 3 minus 3 is 0, 0 times anything is 0. So this will just cancel to 0. So you already get that p of 3 is equal to just our remainder, 2. Similarly, from the next equation, if you plug in x equal to 5, you get p of 5 is equal to 4. So, now that we know that, let's look at our final equation. P of x equals x minus 3 times x minus 5 times q of x plus ax plus b. So, now we can say that plug in x equal to 3. That means that p of 3 is equal to ax plus b, because the entire first terms will cancel. So p of 3 equals ax plus b. And then if you plug in x equal to 5, then again these terms cancel. Oh, I'm sorry. I forgot to plug in that when this is also 3. So this is actually just going to be 3a plus b because x equals 3. And p of 5 is equal to, when you plug this in, these first terms will cancel over here, these ones. And you're just left with, you plug this in, this becomes 5a plus b. You know that p of 3 is already 2, so 3a plus b equals 2. And you know that p of 5 is already 4, so 5a plus b equals 4. So now we can solve these. We can subtract the first equation from the second equation to get 2a equals 2. That means that a equals 1. And that means that when a equals 1, b equals minus 1. So we realize then that our answer is just going to simply be ax plus b, or when you plug in a and b, a equals 1 and b equals minus 1, 1x minus 1, which just simplifies to x minus 1, which is our final answer. Alright, thank you for watching this video, and I will see you in the next one. Bye!